Hello everyone, this is the Virtual Internship Program by AIN AI. I am doing as a data scientist at AIN AI. The project title is Machine Learning for Predictive Analytics, and the aim of the project is to reduce the monthly churn by identifying high-risk customers well in advance. So machine learning probably plays a very critical role in this so that the company can be in the higher profit side if they are using the predictive analytics for predicting their high-risk customers well in advance. And the aim is to build a classification model to predict churn as 1 month in advance and identify the key churn drivers. So let's move on to the project. Here I am importing the necessary packages, and here I am reading the data and doing the initial processing phases to begin. And importing the data, I am importing the data set, and I am exploring the shape of the data set, the size, summary, dimension, and length of the data set, which we can see here. And we can see the maximum values for each of the columns or attributes, and the count for each of the columns or attributes. And this is the dimension of the data set, and here you can see the information of the data set with the data types listed below. And here's the length of the data set, and we can first see the number of customers having 0 monthly revenue. The number of customers having 0 monthly revenue is 9, so I'm going to remove that as it have some certain impact on the model. And I'm also going to remove the NIN values in the monthly revenue, and I'm going to display the dataset after filtering it. And here I'm going to find the missing value percentage, which is greater than 5%. If it is greater than 5%, I'm going to remove that attribute. Here we can see none of the columns have greater than 5%, so I'm going to leave it as it is. We can do any other operation like imputing the missing variables with mean and median. And you can see some of the results I have listed below. You can check that in my GitHub code. And here I'm going to remove the 1% outliers in the column, unique subs and director assisted calls. And you can see the unique subs. Here we can see an outlier, here we can see an outlier. I'm going to remove that using quantile function. And I'm going to drop the columns having those outliers, and I'm going to replotting to check for the outliers. Here we can see that outliers have been removed. And after that, we are going to do some exploratory data analysis for the prediction of customer churn. I'm going to plot monthly revenue versus the overage minutes. And with monthly revenue and overage minutes, we can see the correlation coefficient is 0.783. So we can see they are highly correlated. So the attributes, both the attributes tends to +1 of the correlation. If the customer works an extra time other than the prepaid allocation, his or her monthly revenue increases and vice versa. So both the variables are strongly correlated. And you can see the cat plot for the active subscribers and the monthly revenues. Here I have drawn some results. You can see high number of active users also have the revenue monthly between 500 to 1000 USD. And the impact of credit rating in churn rate. We can see the credit rating plot with respect to churn rate. I have here drawn the conclusions, and I have done some exploratory data analysis to analyze customer churn. And also I have also plotted some distribution of the numeric variables with respect to churn, but I don't see any striking patterns here. So let's move on and do the same for the categorical variables. Here also I can't see any specific patterns, so we have to do it further. I'm going to plot the null percentage of values, null values in the columns. We can see the total null values in each of the columns. And I'm going to plot the correlation matrix here. After that, we are going to see which variables are strongly correlated as my infector model, and we can deal with that later. And let's plot the revenue distribution of the customers. Looks like the mean monthly value lies between the 0 and 100,000 USD, and here high number of customers are the monthly revenue less than the mean value. And percentage of subscribers churn, we can see it in the pie chart. And success rate of the retention calls, we can see success rate is 0.599. And the success rate of retention calls, I have drawn some conclusions here. You can check that in the GitHub code. And success rate of retention offer is 0.590. And number of incomes per customers per income group, I have plotted in the chart, and we can see some of the conclusions here. And let's move on to the feature engineering techniques and creating additional features to help predict churn. I am creating some additional features such as percentage of roaming calls and etc. And I'm going to do some data manipulation techniques. Here we can see encoding service area into city, neighborhood, and states. Since it has high cardinality of 747 unique values, so if we do some encoding, we can get 747 unique rows. In order to avoid that, I'm going to split it into two columns, states and city, neighborhood. and I'm going to separate the categorical values into multiple values and binary values. You can see the binary columns here and the multiple columns here. This applicable only the categorical. These are the unique values each of the attributes is having. And I'm going to remove the attributes which are having unknown category with a larger percentage. So I am going to remove handset, price, home ownership, and the marital status. And it's time for the correlation check. We can see these are the variables that are highly correlated. So I'm going to remove these. And I'm going to encode in the categorical features in the data set using label encoder. And we can see after that I'm going to target encoding the target feature with 0 and 1. And finally we are getting a clean data frame. I'm going with the missing values. I'm going to use the KNN imputer and plotting the number of missing values in the each attribute to visualize it. I'm going to use the KNN imputer with neighbors with size 5. And finally the data frame is available for prediction and evaluation. Here I'm going to build a logistic regression model. First of all, I'm going to split the data set into train and test set, and I'm going to perform some standard scaling process in order to do some feature scaling. Here, since the data set is biased, I'm going to do some oversampling techniques here, which is the random oversampler, and I'm going to build the logistic regression model. And here we can see the confusion matrix. Here true positive rate is quite high, but also the false positive rate is also high and false negative rate is also quite high. But I'm going to get an accuracy of mediocre accuracy of 0.59, and this is the classification report, and this is the Gini value, and this is the prediction values and target values. Some of the values are incorrectly predicted, and I'm going to do a probability threshold in order to increase the accuracy. This is the precision recall curve, and after that I'm going to set some probability threshold value in order to increase the accuracy and precision value. Here we can see the accuracy is increase up to 0.63%. And plotting the ROC curve and finding the area under the curve. The area under the curve is 0.587, and this is the final classification report, which is accuracy 0.60%. And here I'm going to build a random forest classifier to compare model accuracy over logistic regression model. Here I'm going to say do the same techniques, and I'm going to plot the correlation confusion matrix. Here we can see the true positive rate is quite high compared to logistic regression and gives an accuracy of about 70%. And the Gini index 0.091, and same by determining the probability threshold, I can increase the accuracy of 0.71, and plotting the ROC curve, we can find the area under the curve, which is 0.5459, and I'm going to optimize the model using hyperparameter tuning using randomized search CE. I'm going to create the grid parameter grid, and using 10-fold cross validation, the best parameters are found using random search. Scoring parameters negative mean squared error, and after doing cross validation techniques with randomized search, I'm going to get the best parameters. And after using the best parameters, I'm going to I'm getting the accuracy 0.72. So the accuracy is increased from 70% to 75%, 72%. Here the overall result has been displayed below. I'm going to identify the important features impacting the churn using the random forest model. These are the top 20 features which are impacting the churn. And I'm going to predict the test data, hold out custom data provided to predict churn using the best model identified. As the best model is identified as random forest, I'm going to use it in the test data. I'm going to do the same feature engineering technique and data manipulation technique as I did for the training data set. So I'm going to skip the comments and jump straight away to the prediction of the customer churn using the data set. Same type of feature engineering is done, and encoding is done. And after that, it's ready for the prediction. Here we can see the same thing is done, and I have predicted the churn rate using custom ready and churn, and this is the rate of the test data set, or churn rate of the test data set, and from that I have drawn some observations. You can see that in my LinkedIn code, GitHub code, and these are some of the suggestions I have done, and that's it. Thank you. Have a good day.